January 1942. An empty training range stretches across frozen ground in the American Northeast. Breath hangs in the air. Snow crunches under boots. A young infantryman adjusts his grip on a long steel tube. Awkward, unpainted, unfamiliar. There is no manual yet. Only instructions passed quickly, almost cautiously. Downrange, a captured steel plate stands in for a German tank. It looks distant, impersonal, invincible. The soldier shoulders the weapon. Behind him, officers step back. No one is certain how much flame will erupt or whether the device will work at all. This is not a rifle, not artillery. It is something new, born not from doctrine, but desperation. A wire is connected. A switch is thrown. The rocket leaves the tube with a violent hiss, tearing through the winter air. For a split second, it seems to drift, then strikes. The steel plate erupts inward, warped and cracked, punched by a force no bullet could deliver. Silence follows, then disbelief. For the first time, an American infantryman has stopped armor with a weapon he can carry alone. And that moment exists only because, in 1942, the United States Army had discovered a terrifying truth. It had gone to war without a way to kill tanks, and the clock was already running. By the time that rocket scorched the winter air in January 1942, the problem it was meant to solve was already 3 years old. In September 1939, German armor columns rolled into Poland with a speed the world had never witnessed. Tanks did not advance slowly behind infantry. They led. They broke through lines, bypassed resistance, and left confusion in their wake. Radios linked vehicles into moving formations. Dive bombers followed armor like hunting birds. Within weeks, Poland collapsed. Military observers took notes. Some warned of a revolution in warfare. Others dismissed it as a regional imbalance, an accident of terrain and preparation. In the United States, those warnings struggled to penetrate a military culture shaped by distance and memory. The last American war against a mechanized enemy had not yet happened. The U.S. Army was small, underfunded, and organized around ideas born in 1918. In that world, tanks were not an infantryman's problem. American doctrine between the wars treated armored threats as targets for artillery, not foot soldiers. Anti-tank defense meant heavy guns, 37mm cannons towed into position by trucks or horses. These weapons required crews, time, and clear lines of fire. They assumed warning. They assumed preparation. They assumed that infantry would not face tanks alone. Europe shattered those assumptions. In May 1940, German panzer divisions punched through the Ardennes, terrain French planners had deemed impassable for armor. Within days, Allied lines unraveled. French and British anti-tank guns were often bypassed or destroyed before they could be deployed. Infantry units found themselves face-to-face with steel they could not stop. Men threw grenades. They fired rifles. They ran. France fell in 6 weeks. American attaches reported home with urgency. German tanks were not invincible, but they were relentless. Infantry units without mobile, immediate anti-armor weapons were helpless once artillery failed or was outpaced. British improvisations, sticky bombs, Molotov cocktails were desperate measures, not solutions. Still, the United States remained at peace. Isolation, geography, and political caution slowed change. The Army expanded slowly. Budgets rose incrementally. Tank destroyer concepts were debated. Committees argued whether infantry should even be tasked with killing tanks. Heavy industry focused on aircraft, ships, and traditional artillery. Meanwhile, Germany turned east. Operation Barbarossa in June 1941 unleashed the largest armored invasion in history. Soviet forces, despite vast numbers, suffered catastrophic losses in the opening months. Once again, tanks dominated the battlefield. Once again, infantry without proper weapons paid the price. Soviet troops responded with close-range explosives, suicide charges, and sheer numbers. The lesson was now unmistakable. Still, the United States had not yet been tested. That changed on December 7th, 1941. Pearl Harbor dragged America into a global war already defined by machines. Within days, planners began asking hard questions. How would American infantry face German Panzer IVs in North Africa? How would soldiers confront Japanese armor in the jungles of the Pacific, where artillery support would be limited and terrain unforgiving? The answers were deeply uncomfortable. In early 1942, the U.S. Army possessed no effective portable infantry anti-tank weapon. The 37mm gun, nicknamed the pea shooter by some, was already showing signs of obsolescence against improved German armor. It was heavy, visible, vulnerable. Worse still, it could not go everywhere infantry went. A rifleman with a tank in front of him had no answer. The Ordnance Department knew this. So did the newly empowered scientific community now mobilize for war. In June 1941, months before Pearl Harbor, President Roosevelt had authorized the creation of the National Defense Research Committee, placing civilian scientists into direct partnership with the military. Radar, proximity fuses, and new explosives were already underway. Anti-tank weapons now joined the list. The question was not whether tanks could be destroyed. Artillery had proven that. The question was whether a single soldier could do it quickly, cheaply, and without support. The idea was radical by American standards. European armies had already begun experimenting. Germany was developing shaped charge weapons designed to focus explosive force inward rather than outward. Britain, facing invasion threats, was working on the PIT, a spring-launched spigot mortar that could penetrate armor at close range. The United States had something else: rockets. The science was not new. Robert H. Goddard, the American pioneer of rocketry, had been launching experimental rockets since before the First World War. His work, largely ignored between the wars, suddenly gained relevance. Rockets offered propulsion without recoil. They could carry explosive charges without requiring heavy barrels or breech mechanisms. Most importantly, they could be fired from the shoulder. The shaped charge, the Monroe effect, made the concept viable. By shaping explosive material around a hollow cone, engineers could focus the blast into a narrow jet capable of punching through steel far thicker than the warhead itself. Velocity mattered less than precision. Even a slow-moving projectile could defeat armor if designed correctly. This changed everything. In late 1941 and early 1942, small teams of scientists and ordnance officers worked with urgency bordering on panic. Prototypes were crude. Wires ran externally. Ignition systems were unreliable. Rockets sometimes failed to detonate or detonated too soon. But the concept worked. Now it needed to be built. Fast. Winchester Repeating Arms Company was an obvious choice. The company had decades of experience in precision manufacturing, firearms production, and rapid wartime scaling. It already supplied rifles and ammunition to the U.S. military. Its factories could adapt. Its workforce understood tolerances and mass production under pressure. Winchester did not design the bazooka alone. The weapon was the product of collaboration between military requirements, civilian science, and industrial execution. But Winchester would be responsible for turning fragile prototypes into something soldiers could trust with their lives. By the spring of 1942, production lines were being repurposed. Steel tubes replaced rifle barrels. Electrical contacts replaced firing pins. Rockets were assembled alongside traditional ammunition. Manuals were written as weapons left the factory. There was no time for perfection. Training lagged behind delivery. Soldiers encountered the weapon for the first time in the field. Early models lacked safety features. Backblast injured careless crews. Misfires were common. Yet despite its flaws, The bazooka represented something unprecedented. For the first time, an American infantryman could look at an approaching tank and know he was not powerless. That shift, technological, psychological, and tactical, would soon be tested under fire, where theory met steel and desperation became doctrine. For the American infantryman of 1942, the tank was not an abstract symbol of modern war. It was noise before sight, a low mechanical growl, the vibration through the ground that reached boots and bones before steel appeared through smoke. Training manuals spoke of coordination and combined arms, but in combat, infantry often met armor alone. Before the bazooka, that encounter was defined by limitation. Rifles could not penetrate armor. Machine guns could suppress vision, but not stop movement. Grenades required suicidal proximity. A tank did not need to aim well to kill. Its presence alone collapsed positions. The bazooka altered that relationship. It did not make infantry equal to tanks, but it made them relevant again. A single soldier, trained and steady, could now wait. He could choose terrain. He could strike at vulnerable angles. The fear remained, but it was no longer paralyzing. Tanks became targets, not inevitabilities. This change was subtle, but profound. Infantry morale shifted the moment soldiers believed they could fight back. The bazooka was not elegant. It was functional. A smooth steel tube, open at both ends. An electrical ignition system powered by dry cell batteries. A rocket stabilized by fins, carrying a shaped charge warhead. There was no recoil, but there was fire, dangerous backblast that demanded discipline and space. Every design choice reflected compromise. Weight had to remain low. Components had to be simple. Materials had to be available in wartime quantities. Reliability mattered more than refinement. Engineers accepted flaws because perfection would arrive too late. The weapon's power came not from speed, but from geometry. The shaped charge focused explosive energy into a narrow jet that could burn through armor plate. Against early and mid-war German tanks, it was enough if fired from the right distance at the right angle. This was not a sniper's weapon. It was an ambush tool. Winchester's factories did not operate in theory. They operated in schedules, quotas, and shortages. The company had to translate laboratory concepts into something repeatable by thousands of workers, many newly hired, many untrained, all under pressure. Tolerances were tight where they mattered and loose where they could be. Electrical contacts had to fire every time. Tubes had to remain straight. Rockets had to fit but not jam. Winchester engineers refined assembly methods, simplified components, and adjusted designs as feedback came back from field. The bazooka evolved even as it was being issued. This was not a finished product delivered to war. It was a living system, changing under combat conditions. Not everyone welcomed the bazooka. Some officers doubted infantry should be trusted with such responsibility. Others feared misuse, friendly casualties, or overconfidence. There were concerns about training time, logistics, and standardization. But battlefield reports spoke louder than theory. When used correctly, the weapon worked. When it failed, the reasons were understood and corrected. Gradually, doctrine adapted. Infantry units were reorganized. Anti-tank teams were designated. Training emphasized patience, positioning, and coordination. Leadership learned that denying infantry a means to fight tanks was more dangerous than empowering them. German tank crews did not initially fear the bazooka. Early encounters were rare. Some rockets failed to penetrate. Others missed. Confidence remained briefly. Then reports changed. Tanks disabled at close range. Crews killed without artillery involvement. Ambushes from terrain previously considered safe. German engineers took notice. So did their weapons designers. Within a year, Germany fielded its own man-portable rocket weapons, directly inspired by captured American designs. The threat was acknowledged. The balance had shifted. The bazooka placed lethal power into individual hands. It forced soldiers to confront tanks not as distant machines, but as vulnerable systems operated by men. Pulling the trigger meant burning through armor and everything inside. This was not celebrated. It was accepted, or demanded it. By late 1942, the bazooka was no longer an experiment. It was part of the infantry's identity, and soon it would be tested not in theory, nor on steel plates, but against real armor, moving, firing, and killing in return. That test would arrive where American forces first met German tanks face to face, and where the weapon's promise would be measured in seconds. The first true test of the bazooka did not come on a proving ground. It came in heat, dust, and confusion, where instructions were incomplete and hesitation could be fatal. In November 1942, American forces landed in North Africa under Operation Torch. It was the United States Army's first large-scale ground confrontation with German forces in Europe's war. Many of the men stepping off landing craft had trained stateside. Few had faced tanks in combat. Fewer still had fired their weapons at living targets. German armor arrived sooner than expected. In Tunisia, Panzer III and Panzer IV units moved quickly through broken terrain, using experience gained on the Eastern Front. They did not wait for set-piece battles. They probed. They struck supply lines. They tested American positions with a confidence born of years of success. For American infantry, this was the moment doctrine ended and reality began. Bazookas were present, but unevenly. Some units had trained with them. Others had barely handled them. Rockets were scarce. Batteries failed in heat and sand. The weapon's backblast betrayed firing positions. Misfires occurred under stress. And yet, in the chaos, the bazooka found its purpose. At close range, often under 100 yards, American soldiers waited in concealment. They aimed for side armor. They fired from shallow angles. When the rocket struck true, German tanks stopped. Tracks shattered. Armor burned inward. Crews bailed out or died inside sealed compartments. These were not cinematic victories. They were sudden, violent, and terrifying for everyone involved. At the Battle of Kasserine Pass in February 1943, American forces suffered a brutal lesson in combined arms warfare. German armor, supported by artillery and experienced infantry, tore through inadequately prepared U.S. positions. Leadership failures were exposed. Units broke. Casualties mounted. But within that defeat, patterns emerged. Bazookas, when positioned correctly and supported by infantry, delayed armored advances. They forced German tanks to maneuver cautiously. They created hesitation where there had been none. They bought time. After Kasserine, changes came fast. Training intensified. Anti-tank teams were formalized. Ammunition supply improved. Electrical ignition systems were simplified to reduce failure. Crews learned to fire and relocate instantly. Terrain became an ally. Olive groves, wadis, ruins. By mid-1943, during the invasion of Sicily, the bazooka was no longer a novelty. It was expected. German tank commanders now advanced with caution in close terrain. Infantry screens widened. Tanks kept distance where possible. The psychological edge had dulled. A single infantryman might now halt a machine weighing 30 tons. Reports from Sicily and Italy confirmed the shift. Bazookas destroyed or disabled tanks, self-propelled guns, and fortified positions. They were not decisive alone, but they were essential. The weapon continued to evolve. The M1A1 removed unnecessary wiring. Later models improved sights and reliability. Lessons from combat fed directly back to factories. Winchester and other producers adjusted designs almost in real time. By the time American forces landed at Salerno and later at Anzio, infantry anti-tank defense had become layered. Mines, artillery, tank destroyers, and now rockets in the hands of foot soldiers. The bazooka had changed the equation. It did not end the tank, but it ended the tank's isolation from consequence at close range. Armor could no longer assume immunity from infantry. Every hedge, wall, and doorway carried risk. By late 1943, the United States Army no longer feared tanks in the same way it had in early 1942. Respect replaced helplessness. Procedure replaced panic. Capability replaced improvisation. And when American forces crossed into Western Europe in 1944, they carried with them not just a weapon, but a lesson learned under fire. Modern war belonged not only to machines, but to the soldiers who adapted fastest. The battlefield had shifted, and its consequences would extend far beyond North Africa and Italy, reshaping how armies armed their infantry for the rest of the century. By the time the smoke settled over the Italian campaign, the bazooka was no longer an emergency solution. It had become a permanent feature of American infantry warfare. Production accelerated through 1943 and into 1944. Winchester, joined by other manufacturers, refined assembly processes to meet the scale of a global war. Thousands of launchers and millions of rockets moved through supply depots toward every active theater. What began as an improvised answer to a crisis was now a standardized item, listed in tables of equipment and embedded in doctrine. The weapon itself continued to change. Early battlefield failures had been recorded in meticulous detail. Electrical ignition systems were simplified to reduce malfunction. Components vulnerable to dirt and moisture were redesigned. Improved warheads increased penetration against thicker armor. Each revision reflected a lesson paid for in blood. The M1A1 and later the M9 Bazooka emerged not from laboratory ideals, but from combat necessity. American infantry units reorganized around the capability. Anti-tank teams became standard at platoon and company levels. Training emphasized concealment, patience, and coordination with riflemen and machine gunners. The bazooka was no longer fired impulsively. It was deployed deliberately as part of a layered defense. Its influence spread beyond American forces. Allied units adopted similar weapons and shared tactical knowledge. German forces, having faced the bazooka in increasing numbers, responded in kind. Captured examples were studied. Within a year, Germany fielded the Panzerfaust and Panzerschreck, simpler, more powerful rocket weapons that mirrored the same philosophy. Infantry must be able to kill tanks. The arms race had descended to the level of the individual soldier. In Normandy, in the hedgerows of France, the bazooka found new relevance. Close terrain neutralized long-range firepower. Tanks advanced slowly, visibility limited. Infantry carried the burden of clearing ground. Bazookas were used against armor, bunkers, and fortified houses. The line between anti-tank and assault weapon blurred. The psychological effect persisted. Tank crews learned to fear narrow roads, villages, and foliage. Infantry learned to exploit that fear. The presence of a bazooka shaped movement even when it was not fired. By 1945, the weapon's influence extended far beyond its physical destruction count. It had altered doctrine. It had rebalanced combined arms warfare. It had proven that technological innovation could arrive fast enough to matter, even in the middle of a global conflict. After the war, the lesson endured. Infantry anti-armor weapons did not disappear. They evolved. Recoilless rifles, guided missiles, and advanced rocket launchers all trace their lineage back to the same realization reached in 1942. Tanks would always dominate open ground, but infantry would always find a way to fight back. The bazooka itself faded from frontline service, replaced by more advanced systems. But its name became permanent, entering language as a symbol of raw, focused power. A reminder of the moment when necessity forced invention, and invention reshaped the battlefield. When the factories slowed and the war ended, the steel tubes cooled. The wires were disconnected. The launchers were stacked and stored. But the change they represented did not end. Because once a single soldier learned he could stop armor alone, warfare could never return to what it had been before. And in that realization, the final meaning of the bazooka quietly took shape. War rarely rewards preparation for the last conflict. It punishes it. In 1942, the United States discovered that industrial strength, manpower, and moral certainty were not enough. Modern war demanded immediacy. It demanded solutions that could move at the speed of the battlefield, carried not by trucks or doctrine, but by individual soldiers making decisions in seconds. The bazooka was not born from vision. It was born from exposure, from watching allies fall, from studying defeats, from realizing too late that infantry had been left behind by machines. Its creation did not signal technological brilliance as much as institutional humility, an admission that old assumptions no longer applied. What followed was not elegance, but effectiveness. A simple steel tube, rushed into service, flawed and dangerous to its own crews, nonetheless restored balance where none had existed. It reminded armies that dominance is temporary, and that every advantage invites a counter. The tank had transformed warfare in the 1930s. The bazooka answered it in the 1940s, not by ending armor, but by forcing it to share the battlefield again. More than a weapon, the bazooka represented a shift in trust. Trust placed in the infantryman to judge distance, timing, and risk. Trust that innovation could come from urgency rather than perfection. Trust that survival sometimes depends on placing power as low as possible in the chain of command. When the war ended, the bazooka remained behind in depots and museums. But its legacy traveled forward into every shoulder-fired rocket, every anti-armor missile, every moment when a single soldier stands against a machine designed to overwhelm him. It proved that in industrial war, adaptation is as decisive as production, and that even in an age of steel and engines, the outcome still turns on the individual, steady hands, steady nerve, and the will to fire when the moment arrives.